Good evening, everyone. My name is Pamela Carvajal Hernandez, and this is my final project for Elementary Statistics V44 for the Spring 2025 semester with Dr. Frederick Topher. Let's get into this. My objective for this project is to gather how age and personal development correlate with each other, and I think this is important because gathering information on habits as well as opinions can show how they relate to factors such as age, lifestyle, and more, so that we can understand where they are coming from. The questions I would want to explore within this project would be 2 qualitative, 2 quantitative, and 1 binary question. And within these questions, we can dive deep into age, which vary from high school students, young adults, grown adults, etc., as well as well-being and productivity. For the qualitative questions, I picked which artists do you usually listen to and where do you shop for clothes. And for the quantitative questions, I picked how old are you, which is answered numerically, as well as how many hours do you spend on personal development, which determines the functionality and well-being of the users being the individuals of this course. For the 2 choice question, I picked are you good at maintaining your grades, which is answered with a yes or no. I wanted to compare the question of how old are you versus how many hours do you spend on well-being, and I hypothesized that age as well as hours spent on productivity line up with each other. For the question of how old are you, I initially generated a pie chart when I should have actually generated a histogram, but from the pie chart alone, we can see that there is a huge variation going on, and I calculated this out of 90 people, and from the pie chart, we can see for 18-year-olds, there are 36 out of 90 people who are 18, including myself, making it that 40% of the people within the course are 18 years old. And we can also see the runner-ups as well, such as the 17, 19, and 20-year-olds. We can see that for 20-year-olds, there are 11 out of 90, meaning that there are approximately 12% of people who are 20 years old. And for the histogram, we can see right away that it's skewed to the right rather than the left. And for my x-axis, the x-axis would be the ages as well, and the y-axis would be the individuals of the course. And from 0 to 20 on the histogram, well, from the histogram, we can technically say from 15 to 20 because it's not like there's a 0-year-old in the class, but from the pie chart, we can see that there is a 15-year-old, meaning that they're the youngest one. So from the histogram, we can see that from 15 to 20 years old, there are a large people who fit within that age group. So I'm estimating the parameter of the age range. So from this chart, we can determine that the value of n would equal to 90 because that is how many people we're collecting data from. The average age, also known as the mean, will show up to be 20.87 right there. You can see that under the mean. And although we can round that up to 21 years old because we don't go around telling people that we're 20.87 years old, but that's personal reference. Next to the mean, we have the variance, which shows how spread out the ages are. In this case, we have a variance of 36.63, indicating that we have a large spread of ages. And we can refer back to the pie chart because we can just see there right away visually that, whoa, there are a bunch of little columns right there. But yeah. The 6.05 on the standard deviation column indicates that ages are 6 years away from the mean at a constant rate. Standard error, however, was something I always found myself confused with, but after trial and error and referring back to the textbook as well as more resources, I learned that in this case, the standard error estimates how much the mean could vary if someone were to repeat the survey that was given to us at the start of the semester, meaning that the higher the decimal, the higher the percentage. And I always found myself confusing the mean with the median and getting their importances mixed up, though I learned that in this scenario, the median is the value that is in the very middle of the table, whereas the mean is just an add up of all the numbers that follows up with dividing how many there are. So the range here would just be the difference between the oldest and the youngest. So in that case, we would have to subtract the maximum from the minimum, the maximum being 49 and the minimum being 15. And for the minimum, The minimum is 15 because that's the youngest person within this course, and the maximum would be 49 because that's the oldest person of the course. And with those two, we can determine the range, which is 34. Quartile 1 indicates that 25% of the people are 18 years or younger, whereas quartile 3 indicates that 75% of the people are 21 or younger. In this slide, I'll be estimating the parameter for the age range. From this chart, we can determine that the average age of people in this course is about 20.87 years old with a 95 confidence level. We can say that we are sure that the average age of everyone is between 19.6 and 22.1 years old. To basically put it in perspective, if I were to take the survey a lot of times, then the average would fall in between 95 out of 100 times. And we can apply the same knowledge for a 90% confidence level. It's just that the range would be a little bit smaller from 19.8 years old to 21.9 years old because we're 5% less confident. And yeah, to summarize, we can determine that the average age is within the 20s region. And over here, I also generated a box plot. And we can see that visually that the people within this course are from 15 to 20. And we can also see the outliers in here as well. And we can see right off the bat how 49 is way over there. And we can also see that in here in the pie chart as well as the histogram. So yeah, and from the for the median, we can see right away how the median is 20 years old. And for how many hours per week do you spend on personal development, I generated a histogram for this, and we can see right away that the histogram is skewed to the right instead of the left. And in this case, the x-axis would be the hours spent per week, and the y-axis would be the number of individuals. And from this alone, we can see from 0 to 5, there are 15 people, or like 15 plus people, who spend about 5 hours on their personal development. And we can see how that drops down to around 13 people who spend 5 to 10 hours, and that rises up again. But then there's a huge drop in there from 15 to 20, which go from 5. So I found that pretty interesting to analyze. And that also dropped again from 20 to 25, and which kept dropping and dropping. And for this, I also wanted to generate a pie chart to see the variance in this, and I also wanted to generate a box plot for this one as well. And we can see right away how there are 4 outliers and how the average would be around 10. I encountered a slight error within making this parameter via StatCrunch. My end value would show that it would be 80 rather than 90 because I intended to calculate 90 people on their hours per week on personal development. But I later found out that it was because the people on StatCrunch would input their answers as 8 hours instead of 8 alone. So that messed up my data a lot initially. However, I eventually found out about it and I fixed it when I realized. So we can apply the same knowledge we had for the previous slide. The N stands for the amount of people we are collecting data for. And in this case, we don't have to do estimations because the mean is collected in hours, which would be around 10.5 hours. And there is a huge variance which shows to be 86.310. Alongside a standard error of 0.98. The median of the amount of hours someone spends on personal development would be about 8 hours, and the range would be 47 because it is calculated from the max to min. The minimum is shown to be 1 hour, and the maximum is shown to be 48 hours. And I think that the person is a gym rat because I did some side calculations, and 48 hours a week would be approximately 8 hours of exercise a day. So I found that pretty interesting to note. And coming back to the variance, we have a high variance of 86.67. And if we refer back to the to the pie chart, we can clearly see that there's a huge variance in there. So I thought that was pretty interesting to see how we can like look at the parameter, or like what the parameter gives us for variance over here, and how we can like also visually see that within the pie chart. And this is also, and we are estimating the parameters on a 95% confidence level and a 90% confidence level as well. The top shows the 95% and the bottom shows the 90%. And from the top, we can determine that the average is 10.5 hours per week, and the standard is 0.98, which shows how accurate the mean can be. And if you look over to the right side, we can see the numbers 8.572 and 12.472. And these would be our confidence intervals for 95%. And what this means is that we can estimate that the actual average rate would range from 8.5 hours to 12.4 hours. And I also wanted to generate a scatter plot for this, and we can see that this is a non-linear scatter plot, and it's not your usual scatter plot. And I also interpreted it as like an inverse scatter plot as well, because as age increases, hours decrease rapidly. And I noticed that younger people tend to spend more time, whereas older people spend less time. And I think it's because older adults, or like older people, are just more busy in general, whereas like young adults, and when I say young adults, I'm like referring to like 18 years or younger. But I feel like young adults have more free time and motivation. Like I myself am an 18-year-old senior at Ventura High School, and although I'm pretty packed with AP classes and honors courses, I still find myself having free time on the weekend and both on the weekdays. And I also wanted to run a regression on this. And our dependent variable would be how many hours per week we spend on personal development, and our independent variable would be how old are you. And from this alone, our estimate would be 11.98, and our standard error would be 5.22, with a DF of 53 and a T-stat of 2.2. And I also ran a correlation test on this, and from what I got from StatCrunch, I got a negative 0.032. And what does this mean? Since correlation values range from -1 to 0 to 1, this would show that there is a low correlation rate, which means that there's no linear relationship whatsoever. And we can refer back to the scatter plot. We can already see that it is clearly not linear, and it's not your usual scatter plot. And I ran a two-paired hypothesis test on this matter, and from the table we can see that there is a strong difference between the two groups. The first column shows that there is a difference between the groups of 10.34, which means that the first group, also known as the age group, had a higher average. The sample difference shows how far apart the groups are, whereas the standard error here shows the random variation that is found in the difference. This T-stat shows how huge the change is compared to the variation. In that case, the higher the number, the more powerful the difference. And the p-value here shows pure luck. Personal thoughts and opinions on age versus the number of hours spent on personal development. There was lack of correlation, and we can visually see that over here within the scatter plot. And I think that it could be because like grown adults are busy and they could be battling responsibilities such as full-time jobs, families, personal problems, etc. Whereas non-adults, or like young adults, also known as like 18 years or younger, they don't really have to struggle with those factors. And I also want to mention like studying methods as well. Maybe some are more efficient than others. And as for my expectations, I expected it, but I also didn't really expect it. Because I initially didn't keep in mind that how adults are way busier than young adults / teenagers. I myself am a pretty busy high school senior, combating AP classes, extracurriculars, studying, etc. But I always find myself having free time, or making free time at the end. And referring back to my hypothesis, my hypothesis was shown to be incorrect. I believe that the hours and age would correlate with one and the other, but based on the data that I generated, that wasn't the case. Testing out other factors. Where do you shop at versus are you good at maintaining your grades? Qualitative versus one binary. For my objective, I want to compare and contrast data set using a histogram graph and a box plot test. And I hypothesize that there will not be much of a difference with the relationship of where someone shops at versus whether they're good at maintaining grades or not. So I made a bar graph for this. And from this alone, we can see that 20 people shop at thrift stores, 18 people shop at Target, 11 people shop for H&M, 5 people shop for JCPenney, and 4 people shop for Shein. And based on this data that we generated, we can see that JCPenney and Shein have the least amount of shoppers, whereas Target and thrift stores are in the lead. And I expected to see like Target and Shein having the most young people in there, but based on the data that I referred back to, I saw that a lot of 18-year-olds went for Target and thrift stores. So I found that pretty interesting to look at. I also generated a pie chart from this, and we can already see off the bat that there is no variation in this whatsoever. So we can see that thrift stores take the lead alongside Target, which comes with H&M, and almost a tie between JCPenney and Shein. And for estimating the parameters for this, I calculated this out of 60 people, and the standard error was shown to be 0.06. And for the z-score, it tells us whether the data point is unusual or not. And I forgot to mention, but for the standard error, we can see that it is very small because we have like little data in here. And my hypothesis was correct because there wasn't really a difference whatsoever. I generated a test between the two, and yeah, we can see alone there that there wasn't really a difference. And I wanted to also generate data from the question of are you good at maintaining your grades? And at first, I found a lot of errors within making the visual. I generated a pie chart for this, but it was supposed to be a yes or no question. But some people within the survey wrote in like all lowercase, and some people responded with somewhat or something else. And so I had to go back to the spreadsheet and manually change that, which was a little time consuming. And yeah, and I estimated this out of 61 people. And out of 61 people, 52 people answered yes, whereas 9 people answered no. And I wanted to determine a chi-square test between the two, and from this alone, we can already see that there isn't much difference at all. We can see over here that the DF is 4, whereas the 4 indicates the amount of columns in there. And for the value, we got 9.75, whereas the p-value, we got 0.044, which indicates the probability. And last but not least, what artist do you listen to? And I wanted to generate this one for fun because there's lots of variants. I mean, music is pretty endless. It's not like there are like 4 genres in the whole world. So seeing what everyone listens to was pretty interesting to look at. And I also generated a bar graph for that. And we can see that there's a huge, like a tall blue mark over there. And within this project, I learned how to generate data from StatCrunch, as well as I learned how to compare and contrast sources of data within parameters. And this makes me feel interested in studying statistics even more. As someone who's pursuing the medical field in the future, I find this pretty interesting to look at and look into. So yeah. As for the future, I would definitely want to obtain a way to get bigger groups of people so that the results could be more accurate. I can also make sure that the questions are easy to understand so that people won't get frustrated trying to comprehend what I'm asking. And if I had more time, I would dive deeper as to asking personal questions about their home lives or whatnot. So that's the end of my project. Thank you for watching.